Okay, YouTube, so I'm back again with something different. First time that I've done a piece of electronics, I think, on YouTube. So I figure why not? Let's do that too. I mean, I do have the degree on it, so why not? Anyway, I'm actually, what I got here, it's it's a DC to DC converter. For those of you that would like to know the model, this is an LM2596 step down voltage regulator. And what it does is that it takes, in this case, 12 volts, which I got out of this battery. Here is a lead acid battery. It's got the meter there. We can show the voltage there, 12.4. It's fully charged, 100%, shown there by the made in China meter. But that came out of a Harley, basically a motorcycle battery, 12 volt, 20 amp hour, that I'm going to use for my light instead of this thing here, which is a 6 volt, 900 milliamp hour nickel metal hydride battery. So as you can see, I've already cut the connector, so I'm going to put that aside. This is a 5-year-old battery. This is a brand new LM2596 power converter. It's a 3 amp adjustable power supply module, and I actually got 10 of these on eBay for $10, free shipping from a super cool seller. And I have the seller information there. Pro Store Accessories, I would think that stands for. This is the amount of feedback they got, over 100,000. And I have, I'm actually going to list their information. I told them I would do this video on a message today, so here I am doing the video. Basically for me, for my YouTube channel, but also for them, because I'll send them the link and see what they think. So anyways, I'm basically just testing this piece of electronics to see if it'll run my 60 LED Sunforce 5-year-old motion detector LED light that I had outside for that long, 5 years, since 2012, that I bought this in Amazon, and it's been working ever since fantastically great. And I have 3 of these outside. I'm pretty sure the batteries are going to start going on them, so I figure I'm just going to buy something to replace them. I'm into the solar stuff now, so why not come up with something ingenious that's going to do the job for those $15 batteries times 3, 45 bucks. So you know what I'm going. I want to save some money. I had that battery laying around, so I figure, you know what, with the battery, $10 and some ingenuity and some solder, I can get this thing going. So like I said, I just went on eBay and found this regulator, this DC to DC converter. Like I said, it is a 3 amp. I got the specs. I'm going to list, and I paid $9.95, like as you can see there. The output ripple is like 30 millivolts, so there should be a drop of a little bit of voltage once the load is there. But in this case, I'm actually going to adjust this potentiometer. You see there, that blue thing with the screw on the top. I'm going to adjust that to 6 volts, which is what the battery rating is, and then I'm going to connect it there. I already installed the other side here. I did my connections and the input. I did my little rig thing, put a fuse, put a switch to be able to turn it on and off. As you can see, it's got that cool LED that turns on, that way you know it's on, it's running. And I already tested some of the voltages, and like I said, like right now with no load, this thing still shows 12.4. Man, I wish this glare would just go away. Yeah, right there. So, but it's 12.4, and it shows it on the meter. I got my voltmeter here. It's taking over the dining room table to do this, but I'll put that on the 20 volt range, and even though the board doesn't have test points, but I should be able to measure into the red and the black to show that there is 6 volts in there. I'm actually got a flashlight here. Due to lack of light, I cannot see very good. So I'm just gonna put that there. And with a one-hand operation, put that there. And I should be able to see some voltage manifest. And right there you see it. It is a 6 volts on the dot. And I actually had this thing running for a little bit, almost 10 minutes, and it stayed at 6 volts. I mean, it came in default as 11.85, something like that. It was almost the top of the potentiometer if you go clockwise. So I took it counterclockwise all the way to 6 volts, and it has been solid 6 volts ever since. I mean, it hasn't moved. And that's actually pretty cool, because it means that the regulator is not only really nice quality, but there's hardly any movement, which will adhere to the specification this thing is looking for. This thing will run the Sunforce at 60 LED. It requires about 1 amp. It runs at about 1 amp. I think I measured the current not too long ago, and it was about 1 amp running through when all the LEDs are on, which in this case, this particular lamp, all the LEDs are still working. Surprisingly and amazingly after 5 years. So terrific product that I bought in Amazon for I think like 39 bucks. And now I'm going to put this thing in there instead of the $15 battery. I got a $1 device that will do the same job with a battery that I took out from my Harley. So basically, that battery is going to feed all the lights through one of these. So since I got 10, I got one for each. I got 7 left. So I can get lights all around the house and run from the one battery, which is pretty neat. Eventually, I'm going to adapt the solar panels that came with this light, and most likely put them in series. I don't know how much voltage they put out, but I'm going to see what I can do to rig up to actually charge up the battery through a controller. And I have a controller laying around in the garage. It's a 20 amp controller, which will be amazingly good for that battery. And it will keep it charged during the day, and then at night I will plug in a charger that will continue to charge the battery at night, especially if it runs out of voltage or charge. If the lights need to stay on for a prolonged period of time. This thing is actually, I'm putting my finger here because that's where the regulator is, and it doesn't even show signs of being warm. Now, keep in mind, there's no load on it. So what I'm going to do, now I'm actually going to plug that in to see if I can initiate the power sequence on the light and put it to work. So if I could just get this, I mean, I'm trying to do this one-handed. I got no helpers tonight, so okay, there you go. I heard a click. So now this thing should be ready to go. Now the switch down here for the light, just in case you do have the same one, I don't know, or you could get one too. Replace the stinking battery, put them on eBay, sell them as a 3-pack for $15 and buy 10 of those and get one of those. I mean, I don't know. But whatever. I mean, you could actually, this thing, if you put it all the way down, it's in the auto mode. And if you put it all the way to the top, it starts. So it proves right there that this thing is just shining. It's just bright. And when it's outside in the dark, it actually shows that light is actually pretty bright. I just see that just went down to 12.3. And it was already going from 4 to 3 anyway, so I don't see that as a big deal. When When I put my finger there again, I don't feel any heat coming out from that regulator, which at 1 amp, I mean, this is rated 3. At 1 amp, I don't foresee those things ever getting hot. If they ever get hotter, if I decide to go bigger, let's say on a double the size lamp, let's say 120 LEDs, 150 maybe, but it's actually going to draw more than 2 amps, then I would consider putting a heatsink on the regulator. And you could actually buy those at the hardware store, the electronic shop, even on eBay. You could get them and just glue it right on the top or fasten it on the top, and you should be all set. This is going to go right in that compartment, just like that. The LED is not going to show. I really don't care about that. What I do know, excuse me, is that when the light is on, I want it to shine and bright just like that. I mean, it still shows 12.3, and the battery will still show 100%. I could probably leave, that's a 20 amp hour battery, and at 1 amp, it should last a very, very long time. Even if I keep this light on, running at 1 amp all night, I mean, at 100%, it will take a long time for this thing to discharge. So even at 1 amp, this thing seems to be very efficient. Still no heat. I mean, I don't feel any heat in there. It's been running maybe already a couple minutes. On the bottom, nothing. So, I mean, I think these little things were amazing for the price. I only paid $1 for that, which is incredible considering the amount of components. Of course, discrete components. What can you say? But they work. And there's some surface mount in there. The regulator is, as you can see it. The LED. I mean, this is not. It doesn't seem to be cheap. There's the LM, just like that, DC to DC, and it doesn't seem to be cheaply made. That's the pretty cool thing. I mean, it seems to have some quality behind it, and I'm thinking that this is just going to be an amazing addition to these lights. With the exception that now, instead of having the light in there or the battery in there, I'm actually going to have the battery in the garage. I'm going to run some cables and basically just from the one battery run a nice, doesn't have to be super thick. Depending on the distance, you want to consider that, but it doesn't really have to be very thick. I mean, I probably won't go any higher than 16 gauge possibly. This is probably just like a 16, something like that. So, and then I went thinner here, so which is what I think I'm going to use anyway. So, I mean, this is not a bad project. It's very simple. It doesn't require a lot of know-how. Just buy the part on eBay and solder the wires. They do come in these nifty bags, anti-static bags. No wiring, so you do have to get the wires. I would get a wire that doesn't have a lot of strands. That way you could thin it with your solder, and that way it sticks to the. It doesn't create a false bridge when it solders. You know, and then you end up with a cold solder joint. So you want to be sure that they're nicely soldered and the solder is shiny and everything looks cool. And then in my case, I'm actually going to use this little plastic envelope, and which it shrinks. This is for a battery. I get it at the hobby shop. Actually, I got this one at Batteries Plus. I bought a piece of this stuff. They gave it to me actually. I think one day I went to buy some batteries, and they gave me a 4.5 long piece of this sheathing for the batteries. So, and I still had it. So I'm actually going to put that in there to hide it and heat shrink it, and then put it right in there. That way it doesn't touch anything and it's not just floating around. So anyways, let me just show the battery again. 100%, still on. I mean, that's basically I just turned it on, 12.3. I mean, this is pretty cool. So now if I put the switch down, it's going to turn off. And now, with the help of the, there you go, with the motion detector, now it turned on. And but what will happen is that after a minute, that will turn off. I can actually increase the time and put it at, let's say, 10 minutes. And, or even, you know, I'm actually going to run it all night just for the heck of it one day and see how those things perform. So that was it, guys. This is just my video for today. I hope you like it and you put this little project into an implementation in your house and save some money on those nickel metal hydride batteries that actually do cost about $15, I think, plus shipping. So other than that, if you like the video, go ahead and like it for me and subscribe if you like. And until the next one, thanks so much.